Most people quietly assume that fire was always there for humans. Warmth, light, cooked food, protection at night. It feels so essential that it is hard to imagine human life without it. Yet for a very long stretch of human history, our ancestors lived in a world where night fell without firelight, where food was eaten raw, and where warmth came only from the body, the landscape, and other humans nearby. The human species did not begin with fire. Our bodies and instincts first formed in a colder and darker world, which leads to a quiet question that still lingers in the background of human history. Before fire became part of daily life, what was ordinary human life actually like? What human life was really like without fire? When the sun drops below the horizon in an open landscape, the change begins quietly. Light fades first. Colours lose their contrast. The ground, which held warmth through the afternoon, slowly releases it back into the air. In the modern world, this moment rarely feels dramatic. Buildings store heat. Electric lights extend the day. A person can move indoors and the temperature hardly changes. Yet for most of human existence, the end of daylight meant something more physical and immediate. It marked the beginning of a different world, one where the human body had to adapt without the protection of fire. Archaeological evidence suggests that controlled fire became common only after a long period of earlier human existence. Before that point, early members of the human lineage lived in landscapes where sunset brought real environmental limits. As the light disappeared, the temperature often dropped quickly, especially in open environments such as savannas, dry plains, or high plateaus. The warmth of the day did not remain long in the air. Soil and stone release heat rapidly once sunlight fades, and without any artificial source of warmth, humans had to experience this transition directly with their bodies. The human body itself carries signs of this deep history. Our skin allows heat to escape efficiently through sweat during the day, a useful trait for moving across warm landscapes. But that same system also means the body cools more easily when the environment cools. Without clothing designed for insulation and without controlled fire, early humans likely depended on natural rhythms of light and temperature to shape their daily movement. As evening approached, activity naturally slowed. Movement required energy, and energy was valuable in environments where food was not guaranteed. The absence of fire meant that warmth could not simply be created when it was needed. Instead, warmth came from sunlight during the day, from the ground that absorbed that sunlight, and from the presence of other bodies nearby. In many natural environments, the temperature difference between day and night can be significant. Even when the day itself feels comfortable, the cooling of air after sunset would have been familiar to every early human group. It did not arrive as a sudden event, but as a gradual pressure on the body. Muscles stiffen slightly in cooler air. Hands lose some sensitivity. Breathing becomes more visible in colder climates. None of these sensations are extreme on their own, but together they shape behavior. A group moving across the landscape would gradually reduce its range as daylight faded, not because a rule demanded it, but because the body naturally responds to cooling and darkness by conserving energy. Evidence from studies of living hunter-gatherer groups suggests that daylight strongly structures daily activity in environments without artificial light. This does not mean ancient humans behaved exactly the same way, but it shows how closely human routines can follow the rising and setting of the sun when technology does not extend the day. For the earliest humans, sunset likely signaled a narrowing of possibilities. Hunting large animals becomes difficult when visibility falls. Gathering plants becomes uncertain when shapes blur into shadow. Paths across uneven ground become harder to read. The landscape itself becomes quieter and more cautious. All of these changes would have been felt long before humans learned to gather around a controlled fire. When the sun disappeared, warmth slowly withdrew from the ground, and the world returned to a cooler state that had existed long before human beings arrived. In that older rhythm of light and cooling air, early humans learned to adjust their movements, their rest, and their expectations to a day that ended when the sun was gone. As daylight fades completely, the landscape enters a state that modern humans rarely experience in full. Without artificial light, night is not simply darker than evening. It becomes a different sensory environment altogether. Vision, which dominates human perception during the day, suddenly loses much of its usefulness. Shapes flatten into silhouettes, colors disappear, depth becomes difficult to judge. In natural environments without moonlight, The ground only a few steps away can blend into the same darkness as the distant horizon. For early humans living without controlled fire, this change imposed a real physical limit on movement and activity. The human eye is adapted primarily for daylight conditions. Compared with many nocturnal animals, humans do not see well in low light. Our eyes can adjust gradually as darkness deepens, but the improvement has limits. Even after adaptation, the level of detail visible at night remains far lower than during the day. This biological constraint would have shaped how early humans used time. As night settled over the landscape, tasks that required precise vision became increasingly difficult. Identifying edible plants, recognizing animal tracks, or navigating uneven terrain would all have become uncertain activities. Archaeological evidence cannot record exactly how individuals experienced these moments, but the physical limits of human vision provide a clear boundary. Darkness narrows the range of reliable perception. This narrowing does not necessarily mean complete inactivity, but it changes what is possible. In environments without firelight, groups likely reduced movement once the sun had disappeared fully below the horizon. The landscape itself encourages this shift. After sunset, many animals that are active during the day begin to settle, while others that prefer darkness begin to move. The sounds of the environment change subtly. Insects become more audible. Nocturnal animals move through vegetation. Air currents cool and carry sound differently across open ground. For humans without artificial light, these changes would have been part of a familiar nightly rhythm. Darkness did not only hide objects, it also altered the balance between species in the environment. Humans are not specialized night hunters. Our teeth, limbs, and senses suggest an evolutionary history built around daylight activity. Without fire, early humans could not easily extend the day beyond sunset. Instead, the human schedule likely remained closely aligned with the cycle of the sun. This pattern still appears today in communities that live with limited artificial lighting. Sleep often begins earlier in the evening and ends closer to sunrise. Such observations do not prove that ancient humans behaved identically, but they show how human physiology responds naturally to a world where light disappears each night. Darkness, therefore, functioned as a boundary that shaped the daily map of human life. During the daylight hours, the landscape offered paths, resources, and possibilities. After nightfall, that map gradually faded. Distance became uncertain. Landmarks lost their clarity. Even familiar areas could feel unfamiliar when viewed in darkness. This does not mean early humans were helpless after sunset. Human hearing, balance, and spatial memory can still function in low light, but the range of confident movement would have been smaller, and caution would likely have increased. The absence of fire meant there was no simple way to restore light once it was gone. Instead, early humans lived within a cycle that had governed the planet long before their species appeared. The sun rose, activity expanded, and the landscape became readable again. Then the sun set, and the world slowly returned to a quieter state where darkness limited what human eyes could safely interpret. When the sun determined the limits of light, it also quietly determined the limits of time. In a world without controlled fire, the human day did not stretch far into the night. Activity expanded with sunrise and gradually narrowed as the sun moved toward the horizon. This rhythm was not a rule imposed by culture or decision. It emerged from the interaction between the human body and the physical environment. Light allowed the landscape to be understood. Darkness slowly removed that understanding. Early humans therefore lived inside a daily window of visibility that was defined almost entirely by the position of the sun. During daylight hours, the environment offered information that the human brain could interpret with relative ease. Footprints could be followed across soil. Differences in color revealed plants, stones, and animal traces. Distance could be judged. Movement across uneven ground became possible. These abilities are so familiar today that they rarely feel remarkable, yet they depend on a level of light that disappears quickly after sunset. Without fire, there was no reliable method for restoring that lost visibility. The length of the human working day would therefore have followed the length of the natural day itself. In many regions of the world, daylight varies across the seasons. In warmer months, the sun remains above the horizon longer, and activity can continue later into the evening. In cooler months, the period of useful daylight becomes shorter. For early human groups living without artificial light, This seasonal change likely influenced how time was experienced. Longer days may have allowed extended travel, gathering, or social interaction in open landscapes. Shorter days would have compressed those same activities into a narrower span of hours. The rhythm of the sun, therefore, shaped not only individual movement, but the structure of shared time within a group. Archaeological evidence suggests that early humans often moved across landscapes to find food, water, and shelter. Such movement required careful observation of the ground and surrounding terrain. When daylight faded, that observation became more difficult. The safest response would often be to reduce travel and remain within familiar areas until light returned. This pattern can still be seen in many animals whose activity follows the sun closely. Humans, although capable of limited movement in darkness, rely strongly on visual cues when navigating unfamiliar ground. The absence of fire meant that the boundary between day and night remained firm. It is important to remember that early humans did not live in permanent darkness once the sun set. The night sky itself often provides small sources of natural light. The moon, when present, can illuminate the landscape enough for slow movement. Starlight offers faint orientation, yet these forms of light are inconsistent. The moon changes across its monthly cycle, and cloud cover can remove even that dim illumination. Early humans therefore experienced nights that varied in brightness, from pale moonlit evenings to periods of near-complete darkness. This variability reinforced the importance of daylight as the most reliable period for complex activity. Over thousands of generations, human life became deeply synchronized with this repeating cycle. Morning light expanded the visible world and invited movement. Midday provided warmth and the clearest view of the landscape. Evening gradually signaled caution as the environment cooled and shadows lengthened. Finally, night arrived, not as a sudden event, but as the closing of a natural boundary that humans could not easily cross without fire. Long before firelight became a gathering point for human groups, the rising and setting of the sun quietly organized the structure of each day. Within that structure, early humans learned to move, rest, and wait for the return of light that would make the world visible again. Long before humans gathered regularly around fire, the human body had already begun adapting to a particular kind of world. That world was warm during the day, often cooler at night, and filled with foods that were eaten raw or only minimally processed. When scientists study the human body today, they often see traces of that earlier environment still present in our biology. These traces do not describe a single moment in history, but they suggest that many aspects of human physiology developed during long periods when fire was not a constant tool of daily life. One of the most visible features of the human body is skin that sweats easily. Compared with many other mammals, humans are able to release heat efficiently through sweating, especially during movement under the sun. This ability allows the body to remain active in warm conditions for long periods of time. Anthropologists often note that this system works best in environments where the sun provides consistent warmth during the day. Yet the same system also means that the human body can lose heat relatively quickly when the surrounding air cools. Without controlled fire, early humans would have depended heavily on natural warmth from sunlight, movement, and proximity to other people in order to remain comfortable. Another aspect of the human body that reflects this long history is the way we process food. Modern humans regularly eat cooked meals, and cooking changes the texture and energy content of many foods. But the human digestive system itself formed gradually across much earlier periods of evolution. Teeth, jaws, and digestive organs suggest a diet that included a mixture of plant materials and animal foods, many of which would have been eaten raw. Raw plant foods can contain fiber that requires prolonged chewing. Raw animal tissues are tougher than cooked meat and demand stronger biting and tearing motions. Early humans likely spent a considerable amount of time chewing food before swallowing it. Studies of living primates show that chewing time can occupy many hours of the day when food is not softened through cooking. The human jaw and teeth are not identical to those of other primates, but they still reveal an evolutionary background shaped by foods that required physical effort to process. The body's use of energy also reflects a long past in which calories were not always abundant. Movement across landscapes required endurance rather than short bursts of speed. Human legs, feet, and balance systems support steady travel across uneven ground. This kind of movement would have been important for finding food, locating water, and maintaining contact with other members of a group. Without fire, These daily activities occurred entirely within the conditions provided by the natural environment. The body had to operate effectively in the temperatures and daylight available at that moment. Warmth did not come from a constant external source. Instead, it came from sunlight, muscular activity, and shared body heat when people rested close together. Archaeological evidence cannot show exactly how warm early humans felt at every moment, but the physical design of the human body suggests a species that remained active in daylight and relied on natural heat from the environment. Over many generations, these biological traits became part of the human condition. The body that exists today still carries the imprint of that earlier relationship with the sun, with raw food, and with the cooling of air after sunset. Only later in human history would fire begin to alter some of these patterns, providing warmth and cooked food that gradually changed how humans interacted with their surroundings. In a world without controlled fire, every meal carried a different kind of effort. Food was not softened by heat, and many plants and animal tissues kept the textures they naturally possessed. Roots remained firm, fibrous stems resisted the teeth, meat from animals retained the toughness of raw muscle. For early humans, eating was not only about finding food, but also about processing it physically with the body itself. Teeth, jaws, and time became the tools that replaced cooking. Anthropologists studying living primates often observe that large portions of the day can be spent chewing. Gorillas, chimpanzees, and other primates may chew plant material for hours in order to break down tough fibers before swallowing. Early humans were not identical to these species, yet they shared some of the same physical challenges when food was eaten without cooking. Raw foods generally require more chewing before they can be digested efficiently. The act of chewing itself becomes part of the process that prepares food for the stomach and intestines. The human jaw is smaller than that of many other primates, but it still reflects an evolutionary past shaped by repetitive chewing motions. Teeth show wear patterns that archaeologists sometimes study in fossil remains. These patterns can reveal how frequently individuals chewed abrasive plant materials or tough food particles over long periods. Such evidence suggests that the daily experience of eating in early human history involved extended mechanical effort before the food could be swallowed and digested. Raw meat presents a different set of challenges. Muscle tissue from animals contains connective fibers that become much softer when heated. Without fire, those fibers remain strong and elastic. Early humans likely used stone tools to cut meat into smaller pieces when such tools were available, which would reduce some of the difficulty. Archaeological discoveries of stone-cutting marks on animal bones suggest that early humans were able to access animal carcasses and remove flesh. Even so, eating raw meat still required biting, tearing, and chewing before the food could be broken down sufficiently. The body's digestive system then continued the work begun by the teeth. Another aspect of raw food is the amount of energy the body must spend processing it. Digesting fibrous plant material and dense animal tissue requires metabolic effort. When food is cooked, heat begins breaking down certain structures in advance, making nutrients easier for the body to absorb. Without cooking, the digestive system must perform more of that work internally. Scientists do not agree on every detail of how early human diets functioned, but many researchers recognize that cooking changes how energy is extracted from food. Before fire became common, early humans depended entirely on the natural form of the foods they gathered or obtained. This situation likely influenced how much time was dedicated to eating, and how the body balanced energy between movement, digestion, and rest. The absence of fire therefore shaped daily life in subtle but persistent ways. A meal did not simply end when food was found. It continued through the long process of chewing, swallowing, and digesting materials that had not been softened by heat. In that earlier stage of human history, the body itself acted as the primary processor of food. Over generations, this rhythm of gathering, chewing, and digesting became part of the ordinary experience of being human. Only much later, when fire began to enter human routines more consistently, would heat gradually transform how food was prepared and how much physical effort was required before a meal could nourish the body. Warmth is something modern humans often notice only when it disappears. A heated room, warm clothing, and cooked food make it easy to forget that the human body constantly exchanges heat with the environment. Yet long before fire became a reliable tool, the human body had to manage warmth using only what nature provided. In that earlier world, heat was not something people could create at will. It had to be gathered slowly from sunlight, movement, and the presence of others nearby. The human body produces heat naturally through metabolism. Every movement of muscle, every process of digestion, and every breath contributes a small amount of warmth. During the day, when the sun warms the air and ground, this internal heat usually combines with environmental warmth to keep the body within a stable range. But when the sun disappears and the surrounding air cools, the balance begins to shift. The body continues to produce heat, yet it also begins to lose it to the cooler environment around it. Without fire, early humans had limited ways to replace that lost warmth. One simple method available to many animals, including humans, is physical closeness. When bodies rest near one another, the heat produced by each individual accumulates within the shared space. Anthropologists studying social mammals often observe this pattern. Primates, for example, frequently sleep in close groups where body heat helps maintain comfort through the night. Humans likely shared similar strategies during long periods before fire was common. Physical closeness does not eliminate the cooling of the environment, but it reduces the rate at which warmth escapes from the group. Another source of warmth during the day came from the landscape itself. Sunlight heats surfaces such as rocks, soil, and vegetation. These materials slowly release stored heat after sunset, especially during the early part of the night. A place that receives sunlight throughout the day might remain slightly warmer than shaded ground nearby. Early humans moving across the landscape would have experienced these differences directly through their feet, skin, and breath. Choosing where to rest could therefore involve subtle environmental signals. The slope of the land, the direction of wind, or the warmth retained by sunlit ground. Archaeological research into ancient campsites sometimes looks for patterns that suggest repeated use of certain locations. Although many factors influence where people choose to stop, environmental comfort likely played a role long before fire provided a consistent source of heat. Movement itself also generates warmth. Muscles convert stored energy into motion, and that motion produces heat as a natural byproduct. During the daylight hours, walking, gathering, or carrying objects would have helped maintain body temperature even when the air was cooler. This is one reason why steady movement across landscapes can remain comfortable even in moderate cold. Once activity slows, however, the body begins to cool more quickly. Without fire, early humans could not rely on an external flame to restore warmth once they stopped moving. Rest, therefore, required attention to surroundings and to the simple strategies that the body itself made possible. These strategies were not dramatic inventions. They were quiet adjustments repeated over many generations. Resting in sheltered areas, staying close to others, and following the warmth of the sun during the day. The human body, shaped through long evolutionary time, carried the ability to function within these conditions. Fire would later become an important addition to human life, but the biological systems that regulate warmth were already present long before flames became a common part of human evenings. Those systems allowed early humans to survive in a world where heat could not be summoned instantly, and where the search for warmth was woven into the ordinary rhythm of each day. Before humans regularly used fire, every meal came directly from the landscape in the form it naturally existed. Nothing was softened by heat. Nothing was boiled or roasted. The foods available to early humans were those that could be gathered, bitten, torn, and chewed using only the body and simple tools. Archaeological research suggests that early human diets were varied and depended heavily on local environments. Different regions offered different plants, animals, and seasonal opportunities. What remained consistent was that all of these foods had to be eaten without cooking. Plant foods likely formed a large portion of what early humans consumed. Wild fruits, when available, would have been among the easier foods to eat raw. Their natural sugars and soft textures require little processing beyond picking and chewing. Yet fruits are often seasonal, appearing only during certain times of the year. Outside of those periods, humans would have relied on other plant parts that were less immediately pleasant to eat. Roots, tubers, and underground plant structures often contain stored nutrients. Many of these foods are firm or fibrous when raw, which means they demand prolonged chewing before swallowing. Some roots may be edible only after certain natural toxins are removed through soaking or other processes, which early humans may have discovered gradually through experience. Because of this, plant gathering required knowledge of local species and their properties. The archaeological record sometimes preserves microscopic traces of plant material on ancient stone tools, suggesting that early humans processed vegetation in various ways. Even without cooking, plants could be cut, crushed, or pounded to make them easier to chew. Animal foods also appear in early archaeological evidence. Bones from large and small animals discovered at ancient sites sometimes show marks created by stone tools. These marks suggest that early humans were able to remove meat from carcasses. In some cases, they may have hunted animals directly. In other situations, they may have accessed carcasses after other predators had already taken part of the animal. Regardless of how the meat was obtained, without fire it would have been eaten raw. Raw meat contains proteins and fats that provide energy, but its texture requires effort to process with the teeth and jaw. Early humans likely used cutting tools to divide meat into smaller strips that could be chewed more easily. Marrow inside bones may also have been an important food source. By breaking bones with stones, early humans could reach the nutrient-rich material within. This behavior is supported by archaeological findings at several early human sites where broken animal bones appear alongside stone tools. Insects and other small creatures may also have contributed to early diets. Many insect species contain protein and fats and can be eaten without cooking. Ethnographic studies of modern human communities show that insects are sometimes gathered intentionally as food. While it is difficult to know how frequently early humans relied on such sources, they represent another form of nutrition available in environments where cooking was not yet part of daily life. The important point is that the human diet before widespread fire use depended entirely on what could be eaten in its natural state. The landscape itself functioned as the pantry, offering foods that varied across seasons and locations. Some foods were easy to chew and digest. Others required patience and physical effort to process. Over long periods of time, early humans developed knowledge about which plants and animals could be eaten safely and where they could be found. This knowledge did not eliminate uncertainty, but it helped groups navigate a world where every meal began with observation of the surrounding environment. Finding food in a world without cooking required patience and constant attention to the surrounding landscape. Early humans could not depend on stored meals waiting in one place. Most foods available in natural environments appear only at certain times or in certain locations. Fruits ripen and disappear within a season. Herd animals move across wide territories. Edible plants grow in specific soils and climates. Because of this, the search for food became one of the central rhythms of daily life. Each day began with the same quiet question: what might be available in the landscape today? In environments where early humans lived, food resources were rarely evenly distributed. Some areas offered clusters of plants or animal activity, while other areas provided little nourishment at all. Groups moving through these environments likely depended on memory and observation to locate useful places. A tree that produced fruit during one season might be visited again the following year. A stream where animals came to drink might become a familiar location for watching and waiting. These patterns did not guarantee success, but they helped guide movement through large territories. Archaeological evidence suggests that early humans traveled regularly across landscapes in search of resources. Stone tools found far from their original sources indicate that people carried materials with them as they moved. Such movement would have allowed groups to follow seasonal changes in plant growth and animal migration. Without cooking, however, food often had to be eaten relatively soon after it was found. Raw meat spoils quickly in warm environments, and many plant foods lose quality after harvesting. This meant that food gathering and food consumption were often closely connected in time. A successful discovery in the landscape could lead directly to eating, rather than long periods of storage. The absence of cooking also influenced the kinds of foods that were practical to gather. Some plants become much easier to digest after heating, which means they may have been less attractive before fire became common. Early humans likely focused on foods that could be eaten safely in their natural state or with simple processing such as cutting or crushing. This limitation did not make the landscape empty of food, but it narrowed the range of reliable options. Knowledge of edible species would therefore have been valuable and gradually shared across generations. The act of gathering food often involved slow observation rather than quick action. A person searching for edible plants might move carefully through an area, watching for leaf shapes, colors, and textures that signaled a familiar species. Hunters watching animals might remain still for long periods, observing patterns of movement or listening for subtle sounds in vegetation. These activities required attention rather than speed. In a world without fire, daylight hours were especially important for this kind of careful perception. The rising sun expanded visibility across the terrain, making it easier to notice the small details that reveal food sources. As the day progressed, individuals and groups likely balanced their efforts between searching for food and maintaining awareness of safety. Large predators also lived in these landscapes, and humans were not the only species interested in the same animals or carcasses. Archaeological evidence sometimes shows signs of multiple predators interacting with the same remains. This suggests that early humans shared environments with other large animals competing for similar resources. The search for food therefore unfolded within a broader ecological system where many species depended on the same landscape. Over generations, early humans developed habits that allowed them to move through this system with increasing familiarity. They learned where food might appear, how seasons changed the availability of plants and animals, and how far they needed to travel to find nourishment. Without cooking, each meal remained closely tied to the immediate environment. The success of a day's search depended not on stored supplies or prepared food, but on the quiet skill of reading the landscape and recognizing what it offered at that particular moment. Even in landscapes that appear rich with life, food is not always available at the exact moment a human needs it. Plants grow according to seasons. Animals move through territories that may suddenly become empty. Water sources shift, and weather changes the visibility of tracks and edible vegetation. For early humans living without cooking or long-term food storage, this uncertainty formed a quiet but constant background to daily life. A successful search for food on one day did not guarantee the same result the next day. In natural ecosystems, abundance and scarcity often follow patterns that repeat over time, but are not perfectly predictable. A grove of trees might produce fruit during certain weeks of the year and then remain bare for months afterward. A herd of animals might pass through an area only briefly before moving to distant grazing grounds. These rhythms meant that early humans had to remain flexible in how they used the landscape. Movement across territory allowed groups to adjust when resources in one area became limited. Archaeological evidence from early human sites often shows that people did not remain permanently in a single place for long periods. Instead, they returned to locations repeatedly at different times, suggesting a pattern of movement that followed changing resources. The absence of cooking placed additional limits on how food could be used once it was found. Cooking can soften tough foods and make certain nutrients easier to absorb. It also allows some foods to be preserved for longer periods. Without fire, many foods had to be eaten relatively soon after they were obtained. Raw plant materials can dry out or lose flavor. Raw meat can spoil quickly, especially in warm climates. This meant that early humans often consumed food close to the time it was gathered or acquired. A large discovery, such as access to an animal carcass, may have provided a brief period of abundance followed by a return to the search for new resources. Because food could not always be counted on, the human body developed ways of managing fluctuating energy intake. When food is scarce, the body can slow certain processes and draw on stored energy reserves. When food becomes available again, those reserves can be replenished. This biological flexibility is not unique to humans. Many animals share similar responses to irregular food supply. However, in humans, the pattern interacts with social behavior. Members of a group can share food with one another, spreading the benefits of a successful discovery across several individuals. Ethnographic studies of some modern hunter-gatherer societies show that food sharing can help reduce the risk that any one person goes without nourishment for long periods. While we cannot assume that ancient humans behaved exactly the same way, cooperation within groups likely helped people cope with uncertain environments. The landscape itself would have provided signals about whether food might be nearby. Bird calls can indicate the presence of fruiting trees or insects. Animal tracks in soil may suggest recent movement through an area. The color of leaves or the smell of ripening plants can hint at edible resources. Over time, early humans would have become skilled at interpreting these signs. This skill did not remove uncertainty, but it improved the chances of locating food before hunger became severe. Living without fire meant that early humans depended entirely on what the environment offered in its natural state. Some days the search might end quickly with a useful discovery. Other days required longer travel and careful observation before anything edible appeared. Through countless generations, humans adapted to this shifting pattern of availability. The rhythm of searching, finding, sharing, and searching again became part of the deeper structure of human life, long before the warmth of firelight ever entered the evening routine. When modern people imagine darkness, they often picture a dim environment where shapes are still faintly visible. Streetlights glow in the distance. Windows release soft light into the night. Even in rural places, the sky often carries a distant reflection of cities far away. Yet the night that surrounded early humans was very different. Without artificial light and without controlled fire, darkness could become deep and complete. Once the sun disappeared and twilight faded, the landscape often returned to a level of darkness that human eyes were not well designed to navigate. The human visual system works best in daylight. Our eyes contain cells that detect light and color, but these cells depend on a certain amount of illumination to function clearly. As the environment grows darker, vision slowly shifts into a mode that is more sensitive to faint light but far less precise. Colors fade first, then small details begin to disappear. Eventually the world becomes a collection of vague outlines rather than clear objects. For early humans without fire, this gradual fading of visual clarity would have been a familiar experience each evening. The last visible features of the landscape would slowly dissolve into shadow as the sky darkened overhead. Natural sources of light sometimes softened this darkness, but they were never fully reliable. The moon can illuminate open ground surprisingly well when it is full, and the sky is clear. In those moments, large shapes in the landscape remain visible, and movement can continue cautiously. Yet the moon changes constantly through its monthly cycle. During certain nights it rises late or disappears entirely from the sky. Clouds can also cover its light. On those evenings, the land may be illuminated only by distant stars. Starlight provides orientation, but it rarely offers enough brightness for confident movement across unfamiliar terrain. Under such conditions, the ground only a few steps away can fade into the same darkness as the horizon. This type of darkness changes how humans perceive the world around them. Sounds become more important than sight. A rustle in dry grass or the call of an animal carries more meaning when visual confirmation is limited. The direction of wind becomes easier to notice. Smells from plants, animals, or water may stand out more clearly in the cooler night air. These sensory shifts do not replace vision, but they help the human mind remain aware of the surrounding environment when light is scarce. Archaeologists cannot directly observe how ancient humans experienced the night, but they can infer some of its importance from the absence of fire at many early sites. Before controlled fire became common, there is little evidence of artificial light sources that would have allowed groups to illuminate large areas after sunset. This suggests that darkness remained a natural boundary in daily life. Activities that depended on detailed visual perception would have been difficult once the sun had disappeared. Instead, night likely became a period of reduced movement, quieter observation, and preparation for rest. The environment itself also changes when darkness arrives. Many animals adjust their behavior according to the cycle of light and shadow. Some species that remain hidden during the day become active after sunset. Others settle into sleep as night spreads across the landscape. Early humans lived within this broader ecological rhythm. They were neither purely daytime nor purely nighttime creatures, but their physical traits suggest a strong reliance on daylight. Without fire, extending the day beyond sunset would have been extremely difficult. The night therefore became a different phase of the environment rather than a simple continuation of daytime life. In that phase, visibility narrowed, sounds carried through cooler air, and the landscape entered a quiet state where humans could no longer rely on sight in the same way they had during the sunlit hours. When darkness removes the clarity of sight, awareness does not disappear. It changes direction. Human perception is not built from vision alone. Hearing, balance, touch, and memory of the surrounding landscape all contribute to the sense of being present in a place. In a world without fire, early humans likely depended on these quieter senses once night arrived. The shift from daylight vision to nighttime awareness would not have happened suddenly. It unfolded gradually as the sky darkened and familiar shapes began to lose their sharp edges. Human hearing becomes particularly important in low light. Sounds that pass unnoticed during the noise of daytime activity can stand out more clearly in the evening air. Footsteps moving through grass, the snapping of small branches, the movement of insects in dry leaves, or the distant call of animals all provide subtle information about the surrounding environment. These sounds do not reveal exact shapes or distances, but they allow the human mind to form a rough understanding of what may be happening nearby. Many animals rely heavily on hearing to detect danger, and humans share part of that sensory capacity. When the environment grows quiet, even small sounds can carry meaning. The cooler air of evening often helps sound travel farther across open ground. Early humans resting in a group might therefore notice changes in the pattern of nighttime sounds around them. A sudden silence among insects, the repeated call of a bird disturbed by movement, or the distant approach of larger animals could signal activity beyond the range of sight. Awareness of these signals does not require clear vision, but it does depend on careful listening. Over generations, human groups likely developed familiarity with the normal soundscape of the places where they rested. Changes in that soundscape would naturally draw attention. Smell may also have played a quiet role in nighttime awareness. Certain plants release stronger scents in cooler evening air. Animals moving through the landscape can leave faint odors that drift with the wind. While human smell is less sensitive than that of many mammals, it still contributes to the perception of surroundings. Combined with hearing and memory of the landscape, these sensory cues could help early humans remain oriented even when darkness limited sight. Memory itself is another powerful tool when light disappears. People who travel repeatedly across the same terrain often develop a mental map of familiar places. The slope of the ground, the position of large rocks, the location of trees, or the direction of water sources can become part of that internal map. When night falls, movement within known areas may still be possible because the body remembers how the land feels underfoot. Steps become slower and more cautious, but the environment is not entirely unknown. Early humans likely relied on this form of spatial memory when resting or shifting position during the night. The important point is that darkness did not leave humans completely unaware of their surroundings. Instead, it reduced the dominance of vision and allowed other senses to guide perception. Hearing became sharper. Smells carried through the cooling air. The memory of familiar ground helped maintain orientation. Together, these elements created a quieter form of awareness that functioned even in the absence of firelight. Yet this awareness still had limits. Without clear vision, distant details remained hidden, and cautious behavior became the safest response. In this way, night shaped human behavior not through fear alone, but through the simple physical limits of perception in a dark environment. As darkness settled fully across the landscape, the range of safe activity gradually narrowed. The loss of reliable vision did not make movement impossible, but it made every step slower and more uncertain. Over long periods of human history, this quiet limitation likely shaped a simple pattern. When daylight disappeared and the world became difficult to read, the most practical response was often to reduce movement and allow the body to rest. In this way, night encouraged stillness not through instruction but through the physical conditions of the environment itself. The human body follows rhythms that respond closely to light. As evening approaches, changes begin to occur inside the body even before darkness is complete. Hormones associated with sleep gradually increase, body temperature shifts slightly, and the mind becomes less alert to complex tasks. Scientists studying modern sleep patterns often observe that human physiology remains strongly tied to the natural cycle of daylight. Artificial lighting has extended human activity far into the night, but the underlying biological signals that respond to fading light are still present. Early humans living without fire would have experienced these signals more directly because no technology interrupted the natural transition between day and night. When the sky darkened, the body itself began preparing for rest. The cooling of air after sunset likely reinforced this process. As temperatures dropped, muscles and skin gradually lost some warmth. Remaining active in cooler air requires additional energy, and energy was a valuable resource in environments where food could not always be guaranteed. Resting conserved that energy. Groups that settled into a sheltered place during the night reduced the need for constant movement and allowed the body to recover from the physical effort of the day. This rest was not necessarily identical to the long, uninterrupted sleep many people expect today. Anthropologists studying sleep patterns in communities with minimal artificial light sometimes observe that nighttime rest can include periods of quiet wakefulness between phases of sleep. The body may drift in and out of lighter and deeper sleep as the night progresses. While we cannot assume that early humans followed the same exact pattern, the general structure of nighttime rest likely included moments of awareness as well as sleep. In environments where darkness limited vision, remaining somewhat alert to surrounding sounds would have been useful. The places chosen for resting also influenced how night was experienced. Groups may have favored locations that provided some form of natural protection from wind or uneven ground. Large trees, shallow depressions in the terrain, or areas sheltered by rock formations could create slightly more stable conditions for resting through the cooler hours of the night. These choices did not eliminate the challenges of darkness, but they reduced exposure to environmental discomfort. Archaeological evidence sometimes reveals repeated use of particular locations across long periods, suggesting that certain landscapes offered advantages for temporary settlement. Without fire, such environmental features likely became especially important when evening approached. The gradual quiet of the night also changed the pace of the surrounding ecosystem. Many daytime animals settled into their own resting places, while nocturnal species began their movements. For humans who depended on daylight for detailed perception, the safest response was often to remain still and allow the hours of darkness to pass. The rising sun would eventually restore warmth and visibility, reopening the landscape for movement and observation. In this way, night functioned as a natural pause in the rhythm of human life. The body cooled, senses adjusted to darkness, and groups rested until light slowly returned to the horizon. When darkness covered the landscape and movement slowed, another quiet question emerged for early humans. Where could the body rest with the least risk? Without controlled fire, the environment offered no simple barrier between humans and the animals that shared the same territory. Fire can discourage predators and illuminate the surroundings, but before it became common, early humans had to depend on the natural features of the landscape to find places that felt relatively secure. These locations did not guarantee safety, but they could reduce certain dangers during the long hours of night. One possible refuge was elevated ground. Even a slight rise in the terrain can provide a wider view of the surrounding environment during the final moments of daylight. From a higher position, the approach of large animals might be easier to notice before darkness becomes complete. Elevated ground also tends to drain water more effectively after rain, creating drier surfaces where people can lie down. Archaeological studies of ancient campsites sometimes show patterns where groups repeatedly used similar elevated areas, though the exact reasons for these choices are not always clear. Another type of place that may have offered protection was the natural shelter formed by rock formations. Overhangs, shallow caves, and the protected sides of cliffs can block wind and create slightly more stable temperatures during the night. Such spaces also reduce the directions from which animals might approach, allowing a group to remain aware of a smaller area around them. Evidence from some archaeological sites suggests that early humans occasionally used rock shelters long before fire became widespread. These shelters do not appear everywhere, however, and many early human groups likely rested in open environments where rock formations were not available. In those open landscapes, vegetation itself could provide a degree of protection. Dense clusters of trees or shrubs sometimes create natural boundaries that are more difficult for large animals to pass through quickly. Sleeping near such vegetation might offer a small advantage by slowing the approach of potential predators. Trees also influence the ground beneath them. Fallen leaves and plant material can form softer surfaces compared with bare soil or stone. While this does not create the comfort of modern bedding, it may have made certain resting places more suitable than others. The direction of wind may also have played a role in choosing where to rest. Wind carries scents and sounds across the landscape. Resting with the wind blowing toward a group from open ground could allow smells and noises from approaching animals to reach the senses earlier. Humans cannot rely on smell as strongly as many other mammals, but even faint cues can provide information when combined with hearing and memory of the surroundings. These subtle environmental signals may have influenced where groups paused for the night. Archaeological evidence cannot capture every detail of how early humans selected resting places, yet it does reveal that humans often returned to certain areas repeatedly. This pattern suggests that some landscapes consistently provided advantages for temporary shelter, water access, or nearby food sources. Over time, familiarity with these places would have increased confidence in using them again. Without fire, Safety during the night depended less on creating barriers and more on choosing locations that naturally reduced risk. In this way, the landscape itself became part of the strategy for resting. Hills, rock formations, vegetation, and wind patterns all offered small clues about where the body might settle with greater comfort until daylight returned. In the absence of fire, safety during the night did not depend only on the place where people rested. It also depended on how individuals positioned themselves within the group. Humans are social beings, and long before permanent shelters or controlled flames became common, the presence of other people likely formed one of the most reliable forms of security available. Resting close together created a shared awareness of the surrounding environment and allowed multiple senses to remain active even while individuals slept. When several people lie near one another, small disturbances in the environment are more likely to be noticed. One person may wake to a sound that others do not immediately hear. Another might shift position if the ground vibrates slightly from movement nearby. These subtle reactions can spread through a group, gradually increasing alertness without the need for full wakefulness. In this way, the group functions as a network of perception rather than a collection of isolated individuals. Even when most members are resting, the combined sensitivity of many ears and bodies can provide a form of collective awareness. This pattern of sleeping close together appears in many social mammals. Primates, for example, often gather in groups when resting at night. Physical closeness provides warmth and reduces the chances that a single individual will face danger alone. Humans share some of these social tendencies, and the evolutionary history of the species suggests that group living has been a central part of human survival for a very long time. Without fire, which can discourage certain animals and illuminate the surroundings, the presence of others may have been one of the most dependable forms of reassurance during the dark hours. Physical closeness also helps the body maintain warmth. Each human body continuously releases heat through the skin and breath. When several people rest near one another, that warmth accumulates in the shared space between them. The effect may be subtle, but over the course of a cool night it can make a noticeable difference. Anthropologists studying traditional sleeping arrangements in some modern communities have observed that people often sleep in close proximity rather than widely separated positions. While these patterns vary across cultures and environments, they demonstrate how shared warmth can naturally emerge from simple proximity. In the deeper past, before the regular use of fire, such closeness may have helped reduce the loss of body heat during cooler hours. Group sleeping also changes the psychological experience of night. Darkness in an open landscape can feel uncertain when a person is alone. Familiar sounds may be harder to interpret, and the mind can become alert to every movement in the environment. When several individuals rest together, that uncertainty may become easier to manage. The presence of others does not remove environmental risks, but it creates a sense that attention to the surroundings is shared. Even if some individuals are asleep, others may remain lightly aware of the environment. Archaeological evidence cannot show exactly how early humans arranged themselves when resting, yet the broader study of human social behavior suggests that group cohesion has long been important for survival. The night environment, with its reduced visibility and cooler air, likely strengthened this tendency. Gathering close together provided warmth, increased sensory awareness, and reinforced the social bonds that connected individuals within the group. In a world without firelight, the human group itself became one of the quiet structures that helped people pass safely through the hours of darkness until morning light returned. Long before beds, blankets, or built shelters existed, the surface of the earth itself became the place where the human body rested each night. Soil, stone, fallen leaves and grasses formed the only sleeping surface available in many environments. This simple reality shaped how early humans experienced rest. The ground was not always comfortable, but it offered certain advantages when people understood how to choose the right place. Across natural landscapes, the texture of the ground can vary greatly. Hard rock surfaces hold warmth during the day, but can feel cold after the sun disappears. Loose sand may remain soft but shifts under movement. Soil mixed with plant material can create a slightly cushioned layer that absorbs pressure from the body. Over time, early humans likely learned to recognize these differences. The selection of a resting place was not only about safety from animals or wind, it also involved subtle attention to how the ground felt beneath the body when lying still for long periods. Fallen leaves and dry grasses may have provided a simple form of natural padding in certain environments. Forest floors often collect layers of plant material that break down slowly over time. These layers create softer ground compared with exposed rock or compacted soil. While this natural bedding did not resemble the comfort of modern sleeping surfaces, it could reduce pressure on joints and muscles during the night. Archaeologists sometimes discover traces of ancient plant materials in areas believed to have been used repeatedly by early humans. In some cases, these materials appear to have been arranged or concentrated, suggesting that people occasionally modified the ground to make it more suitable for resting. Such evidence remains limited, but it hints that early humans may have made small adjustments to the landscape when possible. Even without deliberate arrangement, the body gradually adapts to resting on natural surfaces. People who spend long periods sleeping on firm ground often develop different patterns of posture compared with those who use soft bedding. The human spine and joints are capable of adjusting to a range of surfaces when movement and activity during the day keep muscles strong. Early humans likely changed sleeping positions frequently throughout the night, shifting weight between the side, back, and curled postures as the body responded to pressure and cooling temperatures. These movements would not have been unusual. Many mammals display similar adjustments during rest as they seek comfortable positions on natural ground. Temperature also influenced how the ground felt at night. During the day, sunlight warms surfaces such as rocks and soil. After sunset, that stored warmth slowly dissipates into the cooler air. In the early part of the night, the ground may still release gentle warmth that can be felt through the skin. Later, as the air continues to cool, the same surface may begin to draw heat away from the body. This changing relationship between the body and the ground likely influenced where early humans chose to rest and how they positioned themselves through the night. The absence of fire meant that no artificial heat source could warm the surrounding area. Instead, the human body interacted directly with the natural thermal cycle of the earth beneath it. In this environment, the ground became more than a surface. It was part of the nightly rhythm of human life. Its texture affected comfort, its temperature influenced warmth, and its materials sometimes offered a thin layer of protection between the body and the harder layers beneath. For countless generations before firelight illuminated human gatherings, the earth itself served quietly as the place where human bodies returned each night to rest. Movement across the landscape was one of the most important activities in early human life. Food, water, and shelter were rarely located in the same place for long periods of time. Because of this, early humans often traveled through large areas as part of their daily routines. Yet the distance a group could cover in a single day was not determined only by strength or motivation. It was shaped by light, temperature, and the limits of the human body in a world without fire. The beginning of the day usually arrived with the gradual appearance of light along the horizon. As the sun rose, the landscape slowly became visible again. Shapes sharpened, colors returned, and the ground revealed paths that had been hidden in darkness. This moment marked the reopening of the world for movement. Without artificial light, the hours immediately after sunrise would have been especially valuable for travel and observation. The air during early morning is often cooler than the middle of the day, allowing people to move comfortably before heat begins to build. Early humans walking across open environments such as grasslands or savannas likely used these cooler hours to begin searching for resources. The human body is well adapted for steady movement over long distances. Our legs, feet, and balance system support a walking pattern that can continue for many hours when necessary. Compared with many animals that rely on short bursts of speed, humans are particularly effective at endurance travel. This ability would have been useful in environments where resources were spread across wide areas. However, endurance does not remove all limits. The time available for safe travel was still tied to the cycle of daylight. Without fire, once darkness returned, it became much harder to continue moving confidently through unfamiliar terrain. This meant that daily travel often had to be completed within the visible portion of the day. The distance covered in that time likely varied depending on the landscape and the goals of the group. In areas where food sources were nearby, movement might remain relatively short and focused. In other environments, longer journeys could occur when people searched for animals, plants, or water sources that lay farther away. Archaeological studies of stone tools sometimes reveal that materials were transported across significant distances from their original sources. These findings suggest that early humans were capable of traveling far when necessary. Yet even during longer journeys, the practical boundary of daylight remained important. As the sun moved toward the horizon, the ability to read the landscape began to fade. Shadows lengthened across the ground, and small obstacles became harder to see. Groups moving through unfamiliar territory would have needed to think about where they might stop before darkness fully arrived. Without fire to provide light or warmth, continuing travel into the night would increase uncertainty and risk. This natural boundary likely encouraged people to slow their pace during the later hours of the day and begin searching for suitable places to rest. In this way, the rising and setting of the sun quietly organized human movement across the land. Morning opened the landscape for exploration and travel. Midday allowed continued movement when necessary, although heat might encourage rest in warmer climates. Evening gradually narrowed the safe range of activity. The world that early humans moved through was therefore not only a physical space but also a daily cycle shaped by light. Every journey began with the return of visibility and ended when darkness once again closed the path ahead. The distance early humans could travel in a day was influenced not only by light but also by the quiet signals coming from the body itself. Walking for many hours across uneven ground gradually changes the way muscles, joints, and breathing feel. At first the body moves easily, responding to the rhythm of steps and the steady pace of the landscape. As time passes, small signs of fatigue begin to appear. Muscles tighten slightly, breathing becomes deeper, and the body begins to use stored energy more carefully. These sensations are natural responses to sustained movement. In a world without fire, where cooked food and stored energy sources were not always available, such physical signals likely played an important role in shaping how far people traveled each day. Heat from the sun also affected daily movement. In many environments where early humans lived, midday temperatures can rise quickly once the sun reaches higher positions in the sky. The human body has an effective system for releasing heat through sweat, which allows movement to continue even when temperatures increase. Yet this process also leads to the loss of water and salts through the skin. Without constant access to stored water supplies, early humans likely paid close attention to the balance between activity and environmental heat. In warmer regions, groups may have slowed their pace during the hottest hours of the day, seeking shade or resting until the air cooled slightly. This pattern appears in many human communities that live in hot climates even today. Resting during intense heat is not a sign of weakness but a practical response to the limits of human physiology. Shade from trees, rock formations, or uneven terrain could offer small pockets of cooler air where the body recovered from extended movement. During these pauses, people may have observed the surrounding environment for signs of food, animals, or water sources before continuing their journey. Fatigue also influenced the rhythm of travel. The muscles of the legs and back work continuously during walking, and over time they require periods of rest to recover. Early humans likely developed a natural pacing system in which movement and rest alternated throughout the day. Short stops might occur after crossing difficult terrain, or after carrying heavy materials such as food or tools. These pauses allowed breathing and heart rate to return to comfortable levels before travel resumed. Archaeological evidence suggests that early humans often used particular areas repeatedly as temporary stopping places. These locations may have offered shade, water, or useful resources nearby. The combination of heat, fatigue, and the limits of daylight created a flexible structure for daily movement. Travel could expand or contract depending on environmental conditions and the needs of the group. Some days might involve only short movements within a familiar territory. Other days could require longer journeys in search of food or new resources. Yet regardless of distance, the body remained closely connected to the environment. The warmth of the sun, the strain in muscles, and the cooling air of evening all signaled when it was time to slow down. Without fire to extend activity into the night, the human day remained closely synchronized with these natural physical cues. Movement continued while the body and environment allowed it, and gradually eased as fatigue and fading light guided people toward rest. As the day slowly moved toward evening, the landscape began sending quiet signals that travel would soon end. The position of the sun lowered, shadows stretched across the ground, and the colors of the environment softened into shades of gray and brown. These changes did not stop movement instantly, but they gradually reduced the reliability of the senses that humans depend on when navigating through unfamiliar terrain. Without fire to provide light, The human ability to move confidently through the world was closely tied to the presence of daylight. When darkness arrived, the landscape did not disappear, but its details became harder to interpret. Human eyes can adjust to low levels of light, yet even after this adjustment, the sharpness of vision remains limited. Uneven ground becomes difficult to judge. Small obstacles such as stones, roots, or holes in the soil may blend into the surrounding darkness. A path that appeared clear during the afternoon might become uncertain once the sun has gone. For a species that relies heavily on vision to coordinate movement, this loss of clarity carries practical consequences. Each step requires greater caution. Each direction must be considered more slowly. Over long distances, such careful movement becomes inefficient and tiring. Night travel also increases uncertainty about the surrounding environment. Many animals change their activity patterns after sunset. Species that remain hidden during daylight often emerge in darkness to search for food or water. Early humans shared these landscapes with a variety of animals whose movements followed different rhythms. Without firelight, which can illuminate a wide area and discourage certain animals from approaching, humans moving through the night would have had less ability to observe these changes around them. The safest response in many situations would have been to reduce movement and remain within familiar surroundings until daylight returned. Another limitation comes from the simple difficulty of orientation in darkness. During the day, landmarks such as trees, hills, and rock formations provide constant reference points that help humans maintain direction while traveling. These visual markers form a mental map of the landscape. When darkness removes the visibility of these landmarks, the map becomes harder to follow. Even people who know a landscape well can lose their sense of direction when visibility falls dramatically. Early humans likely experienced the same challenge. Without artificial light or marked pathways, continuing a long journey through the night would have required slow and cautious progress, which reduced the advantages of traveling in the first place. The body itself also encourages stillness as evening deepens. After hours of movement, muscles begin to accumulate fatigue. The cooling of air signals that nighttime conditions are approaching. These environmental cues combine with internal biological rhythms that prepare the body for rest. When darkness, fatigue, and cooling temperatures appear together, the most efficient response is often to pause rather than continue traveling. In this way, the boundary between day and night naturally shaped the geography of human movement. The land that could be explored during daylight became temporarily unreachable after sunset. Early humans did not wander endlessly across the landscape at all hours. Instead, their journeys unfolded within a daily window defined by light. As long as the sun remained above the horizon, the world was readable and movement remained practical. When the sun disappeared and darkness settled across the ground, the safest and most efficient path was often the one that led to stillness until morning light slowly reopened the landscape again. Warmth in the natural world rarely belongs to a single source. Sunlight warms the ground during the day. Rocks slowly release stored heat as evening arrives. The human body itself produces warmth through every movement and breath. Long before fire became a dependable part of human life, these natural forms of heat shaped how people experienced comfort and survival. In that earlier world, warmth was something that individuals gathered not only from the environment but also from one another. The human body continuously generates heat through metabolism. Muscles convert chemical energy into motion, and even at rest the body produces a steady flow of warmth. When a person sits or lies alone in cool air, that heat slowly escapes into the surrounding environment. But when several people remain close together, the warmth released by each body accumulates in the small space between them. The effect may appear subtle at first, yet over time it creates a noticeably warmer microenvironment compared with the open air nearby. This basic principle can be observed across many species of social animals. Groups of mammals often cluster together during rest, especially in cooler conditions, allowing shared body heat to reduce the loss of warmth to the surrounding air. Humans, as a deeply social species, likely experienced similar patterns long before firelight illuminated human gatherings. In environments where nights could become cool after sunset, remaining close together may have been a practical way to conserve energy that would otherwise be spent maintaining body temperature. Anthropologists studying the social structure of early humans often emphasized that survival depended heavily on cooperation within small groups. Food gathering, protection, and the care of young individuals all required coordination among several people. Shared warmth may have quietly reinforced these connections. When individuals rested close to one another during the night, the physical presence of the group created a space where warmth, awareness, and security were distributed among its members. The environment itself played a role in how this shared warmth functioned. Areas protected from strong winds would help prevent the rapid loss of body heat. Natural depressions in the terrain or clusters of vegetation could reduce air movement, allowing the warmth generated by several bodies to remain concentrated for longer periods. In these sheltered spaces, a small group resting close together might create a pocket of slightly warmer air compared with the open landscape around them. Such differences might not seem dramatic, but over many hours of nighttime rest, they could influence comfort and energy conservation. This relationship between human bodies and the surrounding environment highlights an important aspect of life before fire. Warmth did not come from a single central source such as a flame. Instead, it emerged from the interaction between sunlight, terrain, and human proximity. During the day, movement under the sun generated heat within muscles and skin. During the night, the simple act of resting together allowed that warmth to remain within the group rather than dispersing into the cool air. Over generations, these patterns of closeness likely became part of the social rhythm of human life. The need for warmth did not only shape physical survival, it also strengthened the bonds that connected individuals within a group, living in a world where fire had not yet become a reliable companion after sunset. When individuals remain physically close for warmth and awareness, the structure of the group itself begins to take shape in subtle ways. In a world without fire, where night brought cooler air and limited visibility, proximity between people was not only practical, but also deeply woven into daily life. The human group became more than a collection of individuals traveling together. It became a shared space where bodies, attention, and routines overlapped. Early human groups were likely small compared with modern communities. Anthropologists often suggest that small bands of individuals move through landscapes together, cooperating to find food and navigate the environment. In such groups, the physical distance between people was rarely large. Movement across the terrain required coordination. Gathering food often involved communication and shared observation. Resting at night encouraged individuals to remain near one another for warmth and awareness. Over time, this repeated closeness could shape how humans experience social connection. When people spend long periods near one another, subtle signals become easier to notice. Small movements, shifts in breathing, and quiet sounds carry information about what others are doing. During rest, the rhythm of breathing from nearby bodies can become part of the surrounding environment. These quiet sensory signals do not require conscious attention, yet they contribute to a shared atmosphere where individuals remain aware of one another even during sleep. Many mammals display similar patterns in which physical proximity strengthens group coordination and mutual awareness. Humans likely shared some of these tendencies long before complex shelters or technologies appeared. The structure of resting arrangements may also have reflected differences in age and experience within the group. Younger individuals often require protection and warmth from older members, while adults maintain awareness of the surrounding environment. Although archaeology cannot reveal exact sleeping arrangements, the biological needs of humans suggest that adults, children, and older individuals remained close enough to benefit from shared warmth and attention during the night. This proximity could help ensure that the most vulnerable members of the group remained within the protective presence of others. Environmental conditions may have influenced how tightly groups gathered together. Cooler nights would encourage closer positions as bodies conserved heat. Warmer conditions might allow individuals to spread out slightly while still remaining within hearing distance of one another. In both situations, the group functioned as a flexible unit that adapted to temperature, terrain, and the number of people present. The absence of fire meant that warmth and awareness came primarily from these human relationships rather than from an external source of light or heat. Over many generations, such patterns of proximity may have contributed to the development of strong social bonds. Humans are known for their capacity to form cooperative relationships, share resources, and communicate through language and gestures. While these abilities developed through many evolutionary pressures, the simple necessity of living close together may have reinforced them in subtle ways. Night after night, individuals rested side by side, listening to the quiet sounds of breathing and movement within the group while the surrounding landscape remained dark. In that shared space of warmth and awareness, human connection became part of the practical structure of survival in a world where fire had not yet become a central presence. As evening settled and the final light faded from the horizon, the landscape entered a quieter phase of the daily cycle. Without controlled fire, the night did not gather people around a central flame or illuminate a shared space of activity. Instead, darkness spread evenly across the land, and human groups adjusted by slowing their movements and settling close together. The evening hours were likely calm periods in which the pace of the day gradually softened. This transition from movement to stillness may have begun long before complete darkness arrived. As the sun lowered in the sky, the air cooled and the landscape shifted in subtle ways. The sounds of insects often grew louder. Birds that had been active during the day returned to resting places. Shadows stretched across the ground, and the sharp outlines of distant hills slowly dissolved into the darker tones of evening. For humans who relied on daylight for clear perception, these signals indicated that the time for long travel and detailed observation was coming to an end. Groups may have gathered in places that offered familiar shelter or comfortable ground, preparing to rest while there was still enough light to observe their surroundings. In the absence of fire, evening did not create a brightly lit social center as it would later in human history. Instead, interaction likely continued in quieter ways. Individuals resting near one another could still speak softly, share food that had been gathered during the day, or observe the fading sky above them. The gradual darkening of the environment naturally encouraged a reduction in activity. Conversations would become quieter as people adjusted to the limits of visibility. Movements slowed as the body prepared for rest. The human voice carries well in calm evening air, so communication within a group did not require large gestures or bright light. Even small sounds could travel clearly when the surrounding landscape became still. The sky itself may have provided one of the most visible features of the evening environment. Without artificial lighting, the appearance of stars would have been far more vivid than in most modern settings. As darkness deepened, the sky gradually filled with points of light. Early humans could have observed these patterns repeatedly across many nights. Although we cannot know exactly what meaning they attached to the stars during the earliest periods of human history, the consistent presence of the night sky would have been a familiar part of the evening experience. The changing phases of the moon also altered how the landscape looked after sunset. On nights when the moon was bright, the ground remained partially visible, and silhouettes of trees or rocks could still be seen. During darker phases of the lunar cycle, the environment returned to a deeper level of shadow where only the faint outlines of the horizon were visible. These variations in nighttime brightness likely influenced how long people remained awake or how closely they gathered together before sleep. Without firelight to dominate the evening, the natural transition between day and night remained uninterrupted. The body responded to fading light, conversations quieted, and groups settled into the shared space of rest. In that stillness, warmth came from the presence of nearby people. An awareness of the environment continued through listening rather than seeing. These quiet evenings formed a regular part of human life, long before flames began to illuminate nighttime gatherings. The rhythm of dusk, darkness, and sleep unfolded according to the same natural cycle that had guided life on the planet for millions of years. For a very long time in human history, fire was not something people could create whenever they wished. Flames appeared in nature long before humans learned how to control them. Lightning strikes, volcanic activity, and natural wildfires occasionally ignited vegetation across landscapes. These events produced heat, light, and smoke that could spread across wide areas. Early humans living in these environments would have encountered fire as a natural phenomenon rather than a dependable tool. The presence of fire in nature was therefore familiar, but its appearance was unpredictable. A wildfire might burn through dry grasslands or forests, and then disappear once fuel was exhausted or rain arrived. During such events, flames could transform the landscape dramatically. Vegetation might be cleared, animals displaced, and the ground left covered with ash and charred wood. For humans observing these changes, fire would have been both powerful and temporary. After the flames faded, only the altered landscape remained. Archaeological research suggests that the relationship between humans and fire developed gradually over very long periods of time. Some of the earliest possible evidence of fire use appears at ancient sites where burned materials are found alongside stone tools or human remains. Interpreting this evidence is not always straightforward. Natural fires can also leave burn traces in the soil, and distinguishing between natural fire and controlled human use requires careful analysis. Scientists therefore study patterns such as repeated layers of burned material, the location of charcoal within living spaces, and the presence of heat-altered stones or bones. These clues can suggest that fire was present in a particular place more consistently than natural events alone would explain. Even when early humans encountered fire in the environment, keeping it alive would not have been simple. Flames require fuel, oxygen, and careful attention. A small fire can fade quickly if wood is not added at the right moment. Rain or wind can extinguish it unexpectedly. Before humans understood reliable methods for producing fire themselves, they may have depended on maintaining flames that began naturally. This would require transporting burning branches or preserving embers for extended periods. Such practices demand constant attention and knowledge of how fire behaves. Because of these challenges, the regular use of fire likely appeared slowly in human history rather than all at once. Different groups may have encountered fire under different circumstances depending on their environment. Some landscapes experience frequent lightning storms that ignite natural fires more often. Other regions see fewer natural flames. These variations could influence how often early humans interacted with fire and how opportunities for learning to manage it appeared. The archaeological record reflects this gradual process. Evidence of fire becomes more common at certain sites over time, suggesting that knowledge of maintaining and using flames slowly expanded. This long transition did not immediately transform every aspect of human life. Early use of fire may have been occasional or limited to certain activities rather than a constant feature of daily living. People who had lived for countless generations without reliable fire already possessed strategies for warmth, rest, and food gathering that did not depend on flames. When fire began to enter human routines more frequently, it likely joined these existing practices rather than replacing them instantly. Over many generations, knowledge about fire's behavior, fuel sources, and benefits would have accumulated within human groups. Gradually, what had once been a rare natural event began to appear more often in the spaces where humans gathered. Keeping fire alive is more difficult than simply finding it. A flame may appear suddenly when lightning strikes dry vegetation, but maintaining that flame over hours or days requires constant attention. Fire needs a steady supply of fuel, protection from strong wind or rain, and a place where heat can continue without spreading uncontrollably. For early humans who had lived for generations without fire as a regular tool, understanding these conditions would have taken time and repeated experience. A burning branch taken from a natural fire might remain lit for a while, but it could easily fade if the wood was damp or if the flame consumed the available fuel too quickly. Carrying fire from one place to another also presents practical challenges. Embers can remain hot for a long time, yet they must be protected carefully to prevent them from dying out. Without containers designed to hold burning material safely, early humans would have needed to improvise with natural objects such as pieces of bark, bundles of dry plant fibers, or hollow sections of wood. Each method would require careful balance between allowing air to reach the ember and preventing the surrounding material from burning too quickly. If the ember cooled too much, the fire would disappear entirely. Another difficulty lies in the unpredictable behavior of flames. Fire does not remain stable unless the surrounding conditions support it. Wind can strengthen flames suddenly, causing them to spread faster than expected. Rain can extinguish them within minutes. Even the size and arrangement of fuel affect how long a fire will continue burning. Large pieces of wood burn slowly but may take longer to ignite. Smaller twigs ignite quickly but disappear just as fast. Learning how different materials respond to heat requires observation across many attempts. For early humans, this knowledge likely developed gradually through trial, attention, and shared learning within groups. Archaeological evidence suggests that once humans began using fire more frequently, certain patterns appeared at ancient living sites. Charcoal fragments, burned bones, and heat-altered stones sometimes occur in concentrated areas rather than scattered randomly across the ground. These patterns hint that fires were being maintained in particular locations rather than appearing only as accidental burns. Yet even with such evidence, researchers remain cautious about interpreting how consistently fire was used at the earliest stages. The presence of burned materials does not automatically prove that fire was controlled continuously. It simply indicates that flames were present at least occasionally in those spaces. Another challenge involved the effort required to gather fuel. A fire cannot continue without a steady supply of burnable material. Dry wood, branches, grasses, and other plant matter must be collected and placed near the flame at the right time. In environments where vegetation is dense, this task may be relatively simple. In more open or sparsely vegetated landscapes, however, suitable fuel may be scattered across larger areas. Early humans who attempted to maintain fire would have needed to gather enough material to keep flames alive through the evening and possibly into the following day. This process added a new layer of responsibility to daily routines that already involved searching for food and water. Because of these difficulties, the control of fire likely spread gradually rather than appearing as a single sudden discovery. Groups may have learned small aspects of fire behavior first, such as how to keep embers alive for short periods or how to protect flames from wind. Over many generations, these pieces of knowledge could accumulate into more reliable practices for maintaining fire within living spaces. What began as an unpredictable natural force slowly became something humans could manage with increasing confidence, though the process unfolded over a very long stretch of time. At some point in the long stretch of human history, fire began to appear more regularly in the places where people gathered. This did not happen suddenly across the entire world. The process unfolded slowly, unevenly, and under different environmental conditions. Some human groups may have encountered opportunities to maintain fire earlier than others, depending on the landscapes they inhabited and the frequency of natural fires in those regions. Over time, however, archaeological evidence begins to show clearer signs that flames were present in the spaces where humans lived, rested, and prepared food. When fire entered these spaces, it introduced something new into the rhythm of evening. For countless generations before this moment, darkness had marked a firm boundary between the activities of the day and the stillness of night. The fading of sunlight gradually ended movement and observation, and the group settled into quiet rest. Firelight changed that boundary slightly. A small flame could extend the presence of light beyond sunset, creating a limited area where shapes remained visible even after the sky turned dark. The circle of light from a fire was never very large, but within that space people could continue certain activities for longer than before. Objects could be seen clearly, hands could move with confidence, faces could be recognized across the glow of the flames. Warmth also began to gather around this light. The heat from burning wood created a small pocket of warmer air that contrasted with the cooler darkness surrounding it. For the human body, which had long relied on sunlight and shared body heat to remain warm, this additional source of warmth represented a subtle shift in how evening felt. People resting near a fire could experience comfort that did not depend entirely on physical closeness to others or the residual warmth stored in the ground from the day. Archaeological sites where repeated fire use occurred often show concentrated areas of ash and charcoal. These areas suggest that fires were maintained in specific places rather than ignited randomly across the ground. Over time, such locations may have become familiar gathering points within temporary camps. The presence of fire could encourage people to sit in a loose circle where light and warmth were strongest. This arrangement may have influenced the way individuals interacted with one another during the evening hours. The flickering movement of flames also created a new visual experience. Unlike the steady light of the sun or moon, fire produces shifting patterns of brightness and shadow. These movements change constantly as wood burns and embers glow. For humans who had lived with the stable rhythms of natural light for so long, the appearance of this dynamic light may have felt unusual at first. Yet over generations it became part of the environment in which people gathered at night. Despite these changes, the arrival of fire did not immediately replace the older patterns of human life. The human body, social structure, and daily routines had developed over long periods without it. Fire gradually joined these patterns rather than transforming them all at once. Night remained cooler than day. Darkness still covered most of the surrounding landscape beyond the small circle of light. Movement across the terrain continued to depend on daylight. But within that small illuminated space, something new had entered human evenings. Light and warmth now remained present for a little longer after the sun had disappeared below the horizon. When fire became a more consistent presence in human gatherings, its influence did not arrive as a sudden transformation. Instead, small changes began to accumulate in daily life. These changes unfolded gradually across generations, interacting with habits that humans had already developed during long periods without fire. The warmth, light, and heat of a flame introduced new possibilities, yet the older rhythms of daylight, movement, and rest still remained deeply rooted in human biology. One of the most noticeable differences appeared in the way evening felt. Before fire was maintained regularly, the fading of sunlight marked a clear shift towards stillness and rest. Darkness limited what could be seen, and cooler air encouraged the body to conserve energy. With a fire burning nearby, a small area remained visible even after the sun disappeared. The glow of flames illuminated faces, hands, and nearby objects, creating a space where certain activities could continue for a while longer. This extension of light did not turn night into day, but it softened the boundary that had once been absolute. Within the circle of firelight, people could observe one another more clearly, share food, or adjust tools that had been used during the day. Warmth from fire also changed how the human body experienced the cooler hours after sunset. Previously, the body relied on sunlight stored in the ground, movement during the day, and shared body heat during rest. Fire introduced another source of warmth that did not depend on physical closeness alone. Sitting near flames allowed muscles to relax in cooler air without losing as much heat to the surrounding environment. This change may have influenced how groups position themselves during the evening, gradually forming gatherings where individuals faced toward the shared center of warmth and light. The preparation of food also began to shift. As fire became more common, heat alters the texture of many plants and animal tissues. Fibers soften, fats melt, and certain nutrients become easier for the body to absorb. Archaeological evidence from later periods shows increasing signs of burned bones and plant remains associated with human activity. These findings suggest that food was sometimes placed near fire or exposed to heat before being eaten. Cooking did not appear instantly as a universal practice, but over time it expanded the range of foods that could be consumed more easily. Foods that were once difficult to chew or digest could become more accessible when exposed to heat. Fire also introduced a new relationship between humans and the materials around them. Stones placed near flames can crack or change color as they heat and cool. Wood produces charcoal that leaves dark traces in the soil. These physical changes appear in archaeological layers that mark repeated human presence in certain locations. By studying these traces, researchers can see how the use of fire slowly became integrated into the spaces where humans rested and worked. Despite these developments, fire did not eliminate the environmental conditions that shaped human life before it. Daylight still determined when people could move confidently across landscapes. The search for food still depended on the availability of plants and animals in the surrounding environment. Night remained a period when the wider landscape beyond the firelight returned to darkness. What changed was the experience within that small, illuminated area. Fire added warmth and visibility to the evening hours, allowing humans to remain awake and aware together for longer than before. When fire began to appear more regularly in human gatherings, the evening hours slowly gained a new character. For countless generations before this change, the fading of sunlight had brought a quiet narrowing of activity. Darkness limited movement and observation, encouraging the body to rest while the landscape settled into nighttime stillness. With the presence of a controlled flame, a small part of that darkness retreated. Light from burning wood did not reach far into the surrounding land, but within its glow the environment remained visible in ways that had not been possible before. The area illuminated by fire was usually small. Beyond a few steps from the flames, darkness still covered the ground and trees. Yet within that circle of light, human faces and gestures could be seen clearly. Hands moving near the fire could handle objects with greater confidence than in the dark. Simple tasks that once had to end with sunset could continue for a little longer. Tools might be adjusted or repaired. Pieces of food could be shared and prepared. These activities were modest, but they introduced a subtle extension to the human day. The glow of fire also created a focal point in the evening environment. Before fire, darkness spread evenly across the landscape and groups settled wherever the ground and surroundings allowed rest. When flames burned at the center of a resting place, attention naturally gathered around that light. People sitting nearby could see one another's expressions and movements in the shifting brightness of the fire. The flicker of flames produced moving patterns of shadow that changed constantly across the ground and nearby objects. These visual changes created an atmosphere that was different from the steady illumination of the sun or moon. Warmth gathered in the same place as the light. As wood burned, heat radiated outward into the cooler air of evening. The human body, which had long depended on sunlight and shared body heat, now had access to an additional source of warmth that did not require constant movement or physical closeness. Sitting near a fire allowed individuals to remain comfortable even as temperatures dropped through the night. This warmth may have encouraged groups to remain awake together longer than they might have in complete darkness. Archaeological evidence from later periods sometimes reveals repeated fire locations within ancient living spaces. Layers of ash and charcoal accumulate in particular spots, suggesting that fires were maintained in familiar positions within camps. These repeated patterns indicate that fire gradually became integrated into the spatial organization of human gatherings. A place near the fire might be used for preparing food, while other areas remained darker and quieter for resting. Such arrangements likely developed gradually as people learned how to maintain flames and organize their surroundings around them. Even with fire present, the wider environment still followed the rhythms of night. Animals moved through the darkness beyond the reach of the firelight. Wind carried sounds across the landscape. The sky remained filled with stars above the small illuminated space where humans gathered. Fire did not remove humans from the natural cycle of day and night. Instead, it created a small island of light and warmth within that cycle. Around that light, people could remain awake together for longer moments, sharing the quiet hours between sunset and sleep in a way that had not been possible before. Fire eventually became so familiar to human life that it is difficult to imagine the species without it. Warmth in cold air, light after sunset, and the transformation of food through heat are experiences that now feel ordinary. Yet when the long history of humanity is viewed carefully, a quieter truth begins to appear. The human body, the rhythms of daily movement, and the structure of small social groups all began to form during a time when fire was not yet a dependable part of life. For countless generations, humans lived in a world where the sun provided the main source of warmth and visibility. Evening meant cooling air, fading light, and the gradual slowing of activity. Rest came not from the comfort of heated spaces, but from the shared warmth of nearby bodies and the shelter of natural landscapes. These conditions shaped the early patterns of human behavior long before flames illuminated the night. Even after fire began to appear more regularly, many of those earlier patterns remained visible. Humans continued to rely on daylight to move across the land with confidence. The search for food still depended on the changing seasons and the knowledge of landscapes that offered plants, animals, and water. The body still followed biological rhythms that responded to light and darkness. Fire added something new to this world, but it did not erase the deeper structure that had already guided human life for thousands of years. Archaeological research allows us to see only fragments of this long transition. Layers of ash in ancient soil, burned bones, and altered stones reveal that fire gradually entered the spaces where people gathered. Yet the quiet skills that humans developed before this change remain just as important in understanding the past. The ability to read the landscape, to move together as a group, to listen for subtle signals in the environment, and to rest within the cooling rhythm of night were all part of human life before firelight became common. These abilities helped the species survive in conditions where warmth and light could not be created at will. In this way, the story of fire is not only about a technological discovery, it is also about the long period of human existence that came before it. That earlier world shaped the body and mind that would later learn how to control flames. The habits formed during those generations, traveling with daylight, resting with darkness, sharing warmth with others, remained part of human life, even as fire slowly expanded what was possible after sunset. Today, flames from stoves, lamps, and countless other sources are so constant that their presence can seem natural. Yet every controlled fire is part of a much longer relationship between humans and the environment. The warmth and light we create now rest on knowledge that emerged slowly across deep time. When the modern world glows with electric light and controlled heat, it can be easy to forget that the human species once lived for generations in a colder and darker evening landscape. And perhaps this leads to a final quiet reflection. If the human body and mind were shaped during those long centuries without fire, how much of that earlier world still lives quietly inside us today?